page 1-6. That's on elimination. We're going to do that tomorrow. All right, so here is a problem where you're trying to figure out what X and Y are, but they're application problems. So Liza has $5 and $20 bills in her wallet. This is a very basic example, so you really could guess and check, or why would you really solve for this in real life? You probably wouldn't, but practicing setting up some equations. She has a total of 12 bills, and she has $120. How many of each type of bill is in her wallet? So your first step is you have to decide what two variables you have in this problem. I have how many $5 bills and how many $20 bills. And you could guess and check. I mean, I have 10 of this and 2 of this, or 6 of this and 6 of this. Does that add up to the right amount of money? But we're trying to practice the algebra. Can you give me an equation that uses this first piece of information that she has a total of 12 bills in her wallet? How could I write an equation with X and Y that represent she has a total of 12 bills? Yeah, so X plus Y equals a total of 12 bills. So I could have 6 and 6, 2 and 10, 1 and 11. All right, now I need a money equation. How much is each X worth? Each X is worth $5. How much is each Y worth? Each Y is worth $20, and if I add it all up, I have 120 total dollars. You'll see a lot of examples that are this exact setup. So there's one, how many things do you have, and what is your total cost or value? All right, how do I do this by substitution? What would be my first step to actually solve this? Yep. Sure, let's get X or Y by itself. So you're saying let's subtract X to the other side, right? So if I subtract X in this top equation, I'm just going to write it down here. Y has to equal 12 minus X, or negative X plus 12, whichever way you write it. What's my next step for substitution? I'm going to circle this. Where should I draw an arrow to? I'm substituting it in for Y in the second equation right there. So let's rewrite the second equation. Now I have 5x plus 20. I'm substituting in 12 minus x, and then the equals 120 stays the same. Now you're right back at where you were yesterday. So what's my next step? Starts with a D. Nope, your lunch, but I'll be wrapped up in case you need to scoot at 11:40, because I don't know. All right, so I'm doing the distributive property. So 5x plus, does anyone know 20 times 12? You just do 2 times 12 and add a 0, right? 240 minus, 20x equals 120. So I distributed, I have 240 and I have minus 20x. What's my next step? Combine my like terms. I have 5 x's and I have negative 20 x's. So I have a total of negative 15 x's. And then I'm just going to kind of show that I put those together, but I'm going to subtract this 240 to the other side. So that would give me negative 120 on the right. So go ahead and divide. Do you guys need calculators? I think they tend to move around for class. So that one doesn't have one. You have one. You have one. There's only one in your bed, right? You have one? You have one? You have one or you need one? I know, but the Chromebook distracts you, I think. I don't always have the Chromebook out. You have one, you have one. You guys all have calculators, right? Okay, perfect. So what is 120 divided by 15, or negative 120 divided by negative 15? Yes, so x is 8. All right, well, this is an application problem. So what does that actually tell me? I have 8 $5 bills, 8 $5 bills. I bet you can tell in your head what you have for $20 bills. Don't really have to do a whole lot of algebra. How many total bills do I have? I have 12 total bills. If 8 of them are 5s, then 4 of them must be 20s. So when you answer an application problem, you don't want to write 8, 4. You want to answer their question, how many type of each bill is in the wallet? 8 5s and 4 20s, and you could check on your calculator, is 8 times 5 plus 4 times 20 equal to $120? Yes, it is. So you could double check that you have the right amount. All right, so this other application problem is a little bit different. It's not a money equation. So it says Burns spent some of his weekend on homework and watching TV. So he's telling you the information in kind of like a cryptic math way. Not that you would really calculate this in real life, but we're practicing to use it on harder problems. So he did these activities for a total of 17 hours. And so here's a separate thought. 2 times the number of homework hours minus 1 is equal to the number of TV hours. How much of each activity did he do? So what are my 2 things I'm interested in? I'm interested in homework versus TV, right? He spent 17 hours doing these things. What's my first equation? It's going to be the same type of equation that we just did in the other example. X plus Y equals 17. Okay, the second equation is going to be, I have to write this out using an equation, but this is just words. This says 2 times the number of homework hours. What is 2 times the number of homework hours? Doesn't that just mean 2x? Right, so don't make it harder than it is. 2x, and then it says the word is equal to. So I should write an equal sign. Then it says the number of TV. Oh, it doesn't say minus 1. I didn't write the minus 1 yet, right? 2 times the number of homework hours minus 1 is equal to. So I want to write a minus 1 and then is equal to. Hey, what you need?
I'm in this class now.
Oh, just today?
Yeah, that's why they called me down.
Oh, okay, sweet. So you have this packet, but someone sits there regularly, but you could sit there today. Okay, but you have this packet, so you can just join right in. We're on page resource 17. Welcome. Maybe it'll get fixed in Power School for me. Okay, I didn't look, but did she just do it? Okay, great. Glad it worked out. Sorry if you missed one of your other classes though.
No, I don't have it.
Oh, okay, okay. So equals y. All right. So 2 times the number of homework hours minus 1 is equal to the number of TV hours. See how this is already set up for substitution? Do you see something by itself? What's by itself? This y right here is by itself. So I'm ready to put this circled stuff into the top equation for that y right there. It's a y, right? So I'm going to say x. I don't really need parentheses because I'm not distributing a negative sign or a 2 or anything. I'm just going to write 2x minus 1 in that spot equals 17. So see if you could do the next step. I'm going to zoom out so you can see maybe what we did. So we're on why don't you just jump in with us on example 2. We're on resource page 17, and then I'll let you use my packet to do the top equation that you missed. Resource 17, yep, that's it. No, we haven't done one. We skipped 1 step. So you're on number 2. So you're adding together your like terms and getting x by itself, and that will be your number of homework hours. And you should be able to figure out, double it and subtract 1, and that'll be your number of TV hours. So we should get 3 x's, and then we're adding 1 to the other side, right? So 3 x's has to be equal to 18. So I heard someone say that x would have to be 6, but what does that actually mean? I did 6 homework hours. If I did 17 total hours of these activities, how much did I spend watching TV? 11 on TV. And do you see how that is doubling 6 and come up with easy ones to start with that are so meaningful. So we'll do a little bit more complicated examples, but the big idea is setting up the actual equations from the word. That's the hardest part. So, that's kind of part 2 of what we're doing this week. We're doing substitution and elimination tomorrow, and then using them in the context of these problems. Okay, so could you flip, and I'll let you do the top one in a minute if you need it, but could you skip page 106? We did the first page, I think, yesterday together, 1 through 4, and then you were working on the back page. I don't know if you all finished the back page of 106, but do you see this next page says 106 more practice? I'd like you to just try like 2 or 3 more. I'm not sure if the bell's gonna ring. If it's 11:40, then you just go to 11:40. It's supposed to be 11:45. We'll just see if it hits the bell. So we're gonna try this page 106. A lot of these are already set up for substitution, but even if you could get through 2 of them or 4 of them, just practice substitution on your own a couple times. Okay, and I can walk around and help you, but like, see how the first one is already set up for you? It already says y equals, so you're ready to plug that in for y in this bottom equation? Yes. Okay. Are people good on trying a couple on their own before lunch? Type it in. But I'm going to type, this is the first equation. So y equals, clear everything out. If you have a plot on, it's like black right now, you want to unhighlight. So none of your stat plots should be on, so turn them all off. In your y1, you're going to put x plus 3, and you're using the variable key for x. The variable key is next to alpha. Don't do alpha x, do the variable key for x. So x plus 3 goes in the first, and then I'm going to arrow down 2x minus 1. Make sure that you use the minus key. So this is like plus minus in division, not the coefficient negative key, which is down here. The minus key is that one. And then if you look at your paper, it says type zoom 6 to see a 10 by 10 viewing window. So I like to just, I don't know who's used the calculator, so I just hit zoom 6 so that I can see my 2 lines and where they intersect. So we want to find that intersection point and have the calculator do it for us without us estimating, it looks about whatever. So I wrote those directions on your paper. So you go to second trace, which is the calculate button, and intersect. So do you see the trace button? Here's where it says calculate. I want to calculate things from my graph. So you hit second trace. What do you want to do? You want to find the intersection points. You're going to choose number 5. And then see how your cursor is blinking on the blue that says first curve. So you're going to hit enter that yes, this is the line of interest. Then the cursor will be blinking on your second curve or your second line. So you hit enter. And then you move your cursor close to where you think the intersection is. And it says, is this your guess? Yeah, that's my guess. So I hit enter a 3rd time, and it's going to tell me that is the intersection point 4, 7. So it's another way to use technology to figure out where the graph's intersection point is. So your solution for number 1, 4, 7. Did everyone kind of get the graphs to show up, and did you get the intersection point to show up? If you didn't, I can look at your calculator and tell you what happened. Did anyone's graph not graph or something? Okay, try typing in example 2, and you'll notice you can't. You actually have to convert this equation first into slope-intercept form. See how you have to be smarter than your technology. Your calculator can't graph that. You have to solve that for y equals just like you did in your quiz. So type one of those into y1 and type the other one into y2. Turn the plot on. Hit enter. Did it not work on this one, or? It's supposed to that snap on. Now you should well, but it's not 3 over 2. actually subtract the 2x, so you have 3y equals negative 2x minus 27, right? Your first step is to move the 2x to the other side. What's your second step? Divide everything through by 3. Y equals negative. That's the button you want to use the negative key for. And then 2 divided by 3, x minus 9. You just use the division symbol for negative 2/3 x. This is the negative sign. It's at the bottom of the calculator. This is the subtraction key, which is to the side of the calculator. If you hit the subtraction key over here, it'll give you an error message. So the calculator is powerful, but only if you know how to convert your equation into y equals and type it in and get it to intersect. This time, you are not going to be able to see your intersection point. So I'm going to put x minus 29 and negative 2/3 x minus 9. And nothing of the intersection point is going to show up on my graph. I just get one red line kind of passing through. And you can think about, what's the y-intercept of this first line? Negative 29. So I can't even see the y-intercept. I need to be able to zoom out to see what's going on. Did anybody not get it to graph that first part? Okay, so read, I gave you the hint on your paper. How do you zoom out? All right, well, I'm not going to do that. Okay, so 2/3 is just negative 2. You hit the divided by symbol, and then yep. You need help? Yep. It says change your window or try Zoom 3. If you hit Zoom 3, enter, it'll take you back out far enough so you can see the intersection point. Zoom 3, enter. What do I equal? All right, clear out what's in there. All right, let's do this first one. X plus 3. We have to have an X. First, take your X right there. All right, but then see the X, not the time symbol. The X key right there. Arrow down. Arrow down. So your other one is negative, so use the negative key. Negative 2 divided by 3. And then minus 3. Yep. And then let's hit Zoom 6 because we don't know who's graph on it. Yep. And you're only going to be able to see. Oh, we did this one, right? In this first equation with this second. Okay, so in this first equation, do this one. Yeah, let's just change the first equation to x minus 29. Oh, if you want to do this one, you can change this equation to 2x minus 1. So did you zoom out and did you hit second calculate intersection? Did you find the answer? I'm on number 2. Did you get, uh-oh, my calculator turned off. Did you get your graph to zoom out? You hit Zoom 3 and the enter key one more time. Then you have to go to calculate the intersection point. Did you do that? So I go to second calculate intersect is choice 5. And it's going to ask me my first curve, second curve, intersection point. So enter for the blue line, enter for the red line, and arrow over to your guess. And you should get 12, negative 17. Did anyone successfully get there? Oh, okay. So some people are successful. You got it to work? Yeah, that's right. So Kim says 12, negative 17 down there. Perfect. Try the next one. You can mess with the window. Yeah, if you know how to mess with the window, that's also a way to zoom out. change your x and y axis bigger. That is all. Okay, try number 3 on your own. See if you can type those two equations in and find the intersection. But it gives you the fluency of typing in, looking at the graph. If you can use a graph on the, test, you could check your answers that way. Did you try one of those? Try typing these in your phone. It was negative. You can actually. Okay, here it is. Now find the yeah, I'm ready. Oh, okay. Okay, but I'm glad that you showed me that you know how to do the steps. So try number 3.